Sudip Gelal, and today I'll be presenting my classing learning project on wine quality classification using CRISPTM methodology. The aim of this project was to develop a machine learning model that predicts whether a wine is good quality or bad quality based on its chemical properties. This helps wineries make faster and more consistent quality decision instead of relying only on export testing. I'd like to share my file. Have a closer look on the file. In stage one, business objective and problem statement. On that very first stages, the first stage is business understanding. In this stage, I identify the problem. Wineries usually use exports to test wines, but uh, this process, this process uh, thing wineries, but this process is expensive and time consuming. So my goal was to build a model that can predict whether a wine is good or bad automatically. The original quality scores rank from 1 to 10, but I converted them into two classes. Good wine for score 6 or above, and bad wine for score 6 below 6. This makes the model easier to use in the real business situation. In first stages, I also talk about assess the current situations, mm, like that. And in stage two, data understanding. Data understanding. In this stage, I try to use the wine quality data set for UCI machine learning repository. I combined the red wine and white wine data sets, giving me 6,497 wine samples. I checked data quality and found no missing values, which means the data set was complete. However, I found duplicate records, so I removed them because duplicates can affect the model's learning. And I also explored the data using graphs. I found the wineries. I, uh, I used the graphs. I found the wineries. Higher alcohol generally had a better quality, while wines with high volatile acidity tended to have lower quality. And in stage three is about data preparations. I go have a long story about these are the graphs I use in data stage two. And then stage three and stage three, data preparations. The data preparation here, I cleaned the data before training the model. First, I converted the quality score into good or bad levels. Then I removed duplicate records and handled extreme values using the IQR capping method. Next, I split the data into 80% training data and 20% testing data. I standardized the data because some machine learning models perform better when all values are on the same scale. Finally, I use smooth to balance the training data because there were more good wines than bad wines. This helped this model both classes fairly. And in stage four, in stage four, have a glance over the stress for modeling. This modeling techniques is this is the very important techniques for this assessment. Now I'll explain the modeling stage, which is the most important part of this project. The purpose of this stage was to find which machine learning model gives the more accurate prediction. Instead of choosing one model, I compared 6 different algorithms because each model learns data in a different way. One logistic regression, one first one is logistic regressions model, and in that model, it is simple classification model. It predicts the probability that a wine belongs to the good or bad category. I use this is the baseline model because it is simple and easy to compare with other models. Second one is k nearest neighbors. The second model was k nearest neighbors, or KNN. KNN predicts the quality of wine by looking at the more similar wines. And for example, if some similar wine are good quality, then one new wine is also predicted to be good. And third one is support vector machine. The support vector model was support vector machines or SVM. This is jobs to find the best boundary that separates good wine from bad wines. It works well when the data is more complex and cannot be separated by simple straight line. And fourth one is decision tree. Decision tree model. It works also like answering a series of simple questions. For example, it is alcohol level high. Is the acidity is low? The acidity is low, or it is easy to understand, but sometimes it memorizes the training data too much. Why? Which is called overfitting. And fifth one is random forest. The fifth model was random forest, and this was the best performing model. Random forest is made of many decisions tree working together. Instead of depending on one tree, it combines prediction from many trees and uses the majority vote. This reduces overfitting, the improves accuracy. In this project, random forests are achieving the highest F1 scores and the best overall performance. So I selected it as a final model. And I also discussed about the six Gaussian naive Bayes model. The final model was Gaussian naive Bayes model. This model predicts using probability. It assumes that all features are independent, but in my data set, many features were related to each other. Because of this, it performed worse than the other models. Hyperparameter meter tuning. After building a six model, I use grid source CV. This automatically tested different parameter setting of for each model and selected the best combination. This improved the performance of each model before comparing them. Explainable AI. Finally, I use SAFe, which is an explainable AI tools. SAFe helped me understand why the model made its predictions. It shows that alcohol, density, volatile acidity, and total sulfur dioxide were the most important features affecting wine quality. This makes the model easier to understand and trust. And the stage five evaluation. Stage five, I talked about the evaluations. Mm, in the evaluation stage, I compared all six models using accuracy, precision, recall, F1 score, and ROCAUC. After comparing the result, random forest achieved the best overall performance. This means it make the most reliable prediction for both good and bad wines. So it was selected as the final model. And in the stage six, the final stage is deployment. In a real winery, the random forest model could be connected to the quality control system. Staff would enter the chemical measurement of a new wine sample, and the model I would quickly predict whether the wine is good or bad. This would help save time, reduce cost, and improve product quality. In conclusion, overall conclusion, I successfully applied all six stages of CRISP-DM methodology. After comparing six machine learning models, random forest was the best performing model. This project shows how machine learning can support faster, more accurate, and more consistent wine quality predictions. That's it, and these are some of the references, but I cannot download the PDF file properly, so I have only some references. Thank you for listening. I'm happy to answer any questions. That's all my presentation.